As mentioned, my name is Kaylyn, and really excited to be here. I think Eric kind of reminded me I'm gonna try to describe what I'm starting to do because I should practice this. So yeah, they are programmatically generated, astronomically accurate 3D models of the night sky. So that's what I do for my profession. The theme here, you see it in the top corner, it's space themed, but this entire talk has absolutely nothing to do with space. I just really liked the theme. But it does have a lot to do with imagination and creativity. So, what I'm going to be talking about is how you can use the art and practice of storytelling to work through your Go code. It's particularly useful if you feel like your Go code is in a good place. Like you might ship it to production, you might say the functionality's there, we're cool with it all, but I have that nagging feeling that it's not quite as pretty as it could be. I feel like it's not quite idiomatic enough. Or if you're a more senior engineer and you have someone on your team coming to you with, okay, my PR has been approved, but I feel like we could redesign this better. I'm not sure where to start. I'm hoping that a lot of these practices can both inspire you out of that creative rut and or help some people on your team in the future. So to kick this off, if you know other languages or come from them, you're probably familiar with this type of pattern of development. It's where you've got your logic kind of in the center, this makes up your world, and it is reaching out into other areas of your repository and saying, okay, I need a bit of information from here, I need a bit of information from there, pulling it together, and that's how you run your code. In Go, we have a nice term for this, which is meaningless, is the word that we use. The Go code review comment section is actually one of my favorite Go resources out there. If you haven't checked it out, I totally recommend. It's about 13 to 14 pages. I literally send it to everybody I work with. Read it over and over. There are tons of gems in here. We use the word meaningless, which can at first sound harsh, particularly if you're coming from a language where using models and utils is a best practice, but we do mean it for a reason. We mean it because in Go, we do not think of how do these things exist. Let's put them all together if they work in similar ways. We think horizontally. We want each of our packages to be complete and tell the entire story from start to finish around an entire domain. So meaningless to us means we don't want to go out to some common place and use functions. We want to bring those into our code and find the appropriate place to use it as often as possible. So I'm going to be digging into this concept of horizontal packages and using this kind of terminology where the package that you are working to refactor is your main story. And you want to keep this in mind because you don't want to mix, even if you do have multiple packages, you want to look at them very individually. You want to think about the story that they are trying to tell one at a time before switching to another one and view those other packages as your supporting stories. As we go through this talk, we are going to cover 4 different sections. So the first will be the outline of your story, how the entire package looks, your main characters that you introduce as you go about your project, paragraph structure, kind of getting into some grammatical areas, and then finally supporting characters, what you can do when you do need to reach out for help and you do need to expand your use cases. So the first of it is your story outline. This is an example of what you often see when you are writing stories or reading stories. You'll have your title, your scene setting, your introduction, and then you get into your plot. And a big thing that I want to bring up is that when you are reading or writing a story, you do not often see a list of characters up front and then they tell you what has happened below. You see a character get introduced and they are working through some problems and they are figuring out what they're going to do. And then another character gets introduced, and it happens sequentially. In Go code, we want it to look very similar. So you set up your package, you have your name, your imports, your initializations. You then create your character types. And when you make your first type, you put underneath it the plot points or the functions that relate back to that type. And you keep sequentially doing it. So this is why we say, we don't want you to have a model. We don't want you to go out and put like a model package with everything listed. We want those types exactly, or at least as close to where you are actually using them. And when you write your code this way, it makes it so that your future self or your peers can start to guess where in your package code is going to live. So what I mean by that is if you see in your initializations, I have a few types and they're going to do 5 different functions, you can guess that the next 5 functions will be in the same order that you called from at the top. It makes it very easy to remove the ambiguity of like, I wonder how I should put all my functions and in what order. Think about it like a story. Tell yourself a literal story and put it in that order, and it should help you out in the future. As we transition and start thinking about the actual semantics that we are using, I've got another quote from this great resource around how you name both your package as well as your types. It's common, and this example might make it seem a little bit obvious, that we don't want to have a type accounts file in the package accounts because then it would be redundant. But this happens more often than you might think. So you might be doing an HTTP router and it's on accounts, and then when you make your functions or make your type, you might make it the get accounts or get accounts by ID. And what Go is talking about is we already know we are in the accounts domain. You don't need to keep using that word. And and I'll show a few ways in which this gets clean moving forward. So we're now going to start talking about the main characters. This is the types that were just mentioned, and there's some cool, I find kind of cool little tricks for how to think about what you want to name. So like I just said, you want to name all of your packages, types, and functions in a way that read like your world has these things, like a noun, and they are doing these things. And when you picture it that way, you start to get structures that look like accounts.file. And what does the file do? The accounts.file can write. The accounts.file can read. The accounts.stream can write, or the accounts.stream can replay. But you start to really see a story coming together, and you start to see how these words become a bit more clear with each other as you put it together. I also find this section right here useful for if you're stuck on naming and you're trying to figure out a better name than whatever you have at the current state. I find it to work backwards from the bottom up. So these last words, the verbs on the end, tend to be, for me and the people that I work with, the easiest to come up with because we know what we have to do to solve this problem. We know we need to save the data or get the data or update it. So we can define those verbs pretty quickly. And then once we've defined those verbs, we can start to really think about what is the type, what is the noun, what is the character that is making all of those actions happen, that is tracking we were successful in those actions, that was making sure as we moved along in our plot, we finish everything, get it done, and can move along successfully in our code. So then I have an easier time creating the type names and the nouns that are a part of it, which leads to, I do tend to find the package name to be the hardest, that like world domain structure. But if you list out your nouns and verbs and you put all those, literally like sometimes we'll type them in like a notepad or something, and we'll look at them and think about them for a couple of days or even a couple of weeks, often we can get to a package name that feels like it really gives some clarity about our goals in this story and in this code moving forward. All right, so the third section is our paragraph structure. This gets a little bit grammatical, but I actually find this to be my favorite area. I think that when the Go language was designed, it was designed so well to be really clear around how to read the code in front of you. This is an example comparing Java and Go, where in Java you have your class that is defining the thing. And then inside of it, you've got your list of stuff that's happening. An important note in Java is that, one, we don't repeat the thing, and two, the first element is the result. That's a little bit less clear as the first thing to see. Then you say, okay, I have my result. Now I know what action is taken to get that result. In Go, you can read our function definitions exactly, almost like a sentence, where you can say the thing is taking this action with this item and that item, which results in X, Y, or Z. That was probably one of my early to Go, like it just felt so clean. It felt so nice. It made me think a lot about how I can use my code in various ways. And there's a couple of details I want to dig into with this. So in the best practices, one of the things that you do, if you notice, I didn't call the thing in the method receiver also the thing or some longer name. I called it T. And that might seem like an anti-pattern for some people. I've heard, especially researchers and science physicians, they always have the horror story of joining a code base and being like, The person before me just used letters for everything, and it just looked like a massive math equation. So we are not saying you want to write your code like that. But what we are saying is that when you are making a method that is taking action on a receiver or a character or a noun type of object, you don't need to keep repeating yourself. It's similar to in a story where you already know the name of your main character. You know that this is the whole thing that your code is about within this function, so you can refer to them by a nickname or a pronoun and use that throughout your function there. And I find that really nice. It makes things pretty clean. It also I think it just explains the why you see so many single or two character method receivers in front of you. Also, this second tip I thought was kind of useful. Don't use the words me or this or self. If you find yourself orienting that way, most likely it means your head is still a little bit thinking about things in an object-oriented way, because you're thinking about, like mentioned in Java, this like omnipresent thing where everything is revolving around that object. Everything is in servitude of the thing at the very top of the page. In Go, we don't have that like omnipresent overlord type aspect. We have a world, we have a domain. So there is no me, there is no this, there is no self. There are just things that are getting jobs done, and we are tracking if they are successful or if they are not. I found that really nice that they called it out. And to dig just a tiny bit further, I wanted to show a couple of examples right around here where you get to say actual sentences. And you could literally, if you wanted to, do an exercise where you write it out. So the thing is reading a book and it has gained some knowledge. The thing has tried to write to a book, but you could say there's some errors here, and maybe you could say, it got an authorization failure. I have actually used this sometimes when I am feeling slightly maybe lazy with my test cases. Because what I've found is sometimes I write a couple of tests and I know that I could be writing more. I know I could be thinking more creatively about the success paths, the failure paths, and then also especially the ways in which my function might succeed but actually it failed. When I do a little bit of like story playing and acting as though all of these things are real people, I find that it makes me feel more confident that I've covered the cases I want to cover. Okay, so the next section is actually around single-use variables. This feels small, it feels a little pedantic, but out of everything I'm presenting, when I do code reviews and find an engineer who asks me a question about how can I make my Go code go from functional to idiomatic, this is the one that I've probably had like the most success with, where success is not did they change it and take out this variable, because okay, that's fine. People are often like, one less memory allocation, you don't have to sell me too hard. But success is understanding why that variable actually hurts readability more than aids it. And so the reason I bring this up is when you define a variable, often at the top of your function, and then you use it underneath, you're often kind of making two different sentences. So one says, here is a thing, that means this. So the time is September 27th. On the next line, when you're using it, we just say there's some API that gives the sentence as an output. So we had GopherCon at the time. You don't write a story like that. You don't really read like that. And it causes sort of a blip in your thought process. Instead, you can do all in one line usage of that variable, getting that time not now right in there, and it reads like a sentence of we had GopherCon on September 27th. It seems simple, but what I've found is one of the things new Go developers often bring up to me is that the code can start to look a little repetitive. They'll say, well, in my file, it's kind of long, and the lines are kind of short, and it's just a lot of initialization, take an action, check your error. Initialization, check, take an action, check your error. They kind of like look through it. And when I see code bases like that, often what I find is that they're perfectly functional, they totally work, but we can probably clean them up in a way that expands out the line where we are taking action to make it more of a complete sentence or a compound sentence even. And it makes the code more readable. Because if your eyes are glazing over as you read this code, if you're sort of feeling like, oh no, there's like a bunch of things, where should I be looking? That increases the chances that you push out a bug. It increases the chances that you aren't thinking about what the code is doing. So what I've found is that when there's a bunch of initializations, and we always just quickly scan for are any of these single use, is there a possibility you want to pull these in? When the engineers start doing it, they're often really surprised by how much better their Go code looks. Because Go code does not enforce a line maximum. Obviously, we don't want it to go forever and be unreadable, but the reason for that is that if you are taking one action and you want to make a full statement that says, I am doing this thing with these items, and here's the result that I'm getting, it can often be encouraged and very idiomatic to put that all in one line. So definitely something to look for in your code, and often a quick win that can really refactor things. So we're at the last section. Before I jump into supporting characters, I want to bring up that these first three areas are really good areas to start with if you're in a code base and feeling a little overwhelmed. So it can sometimes feel like if you're in a new code base and you don't like how it looks, that you just sort of want to throw your hands up and say, let's do a rewrite. Instead of doing that, these three areas can often help you start to refactor one singular package, make it less overwhelming, and often be kind of surprising that your results make it clearer how you go deeper into your refactor. The deeper part of your refactor is often around how you have packages interfacing with each other and how you have them talking to each other. So this final point that I really want to bring up goes back to the concept of main stories and supporting stories and how they interleave with each other. Again, really important to think about the package you are working in, the package you are writing code for or refactoring for is the owner of all this. So the advice that comes from the Go team is that Go interfaces generally belong in the package that uses the value of this interface type, and they do not belong in the package that implements those values. We often use the term consumer and producer. The consumer writes the interfaces and owns the interfaces. The producer does not. In many other languages, it works the other way, where the producer exposes an interface that is open, it has everything they want to export, and then the client just pulls what they need. What I've noticed is that when Go developers find this line, they say, you know, okay, cool, I'll just make my interfaces and my clients, like, not a big deal. What I want to discuss is a little bit more of why we do that, and also some ways to try to think about sort of the elegance of this design pattern and what it offers you as you're developing. So when you need a dependency in a story-like setting, you can look at a call out for a dependency as saying your main characters, your main types, are trying to solve a problem and they need some help. Maybe they're struggling with something. Maybe they just can't solve all of what needs to happen in the action alone. Very common. And instead of having the main character write all the code, do everything on its own, you want to call out to another storyline. That's a perfect time to be pulling in from these supporting stories, and what you define inside of your package is the interface where you say, okay, I need help in this exact way. So I'm going to send you this information, and my expectation is that you are going to send this type of information back. This is important in Go code, in all code, because you want to define that interaction. But if you look at it like a story perspective, it also makes sure that your character doesn't like come over from the supporting story and run the show. You don't want them to be driving your main package. You want them to be supporting your main package. And that's a really strong pattern that I think Go for me helped me understand why this is beneficial, and I have absolutely used this in my day-to-day code where my dependency might be a database, and absolutely I've switched from one database type to another. When your client drives, when your main package drives the interaction model, it opens up flexibility for you to receive help from other packages in various different ways. This also allows the producer package, the supporting package, to be looked at more independently so that the code there can be used and continue to be developed on its own without causing as much overlap between the two. Okay, so this covers kind of the main sections of the presentation. What I want to end on is you may have at some point in your life heard about the hero's journey. I'm in fact not actually like a short story person, but I have heard about these, and I was impressed how when I looked at all of the sort of drudgery that the hero has to go through, the work that they have to do, it like really kind of lines up to a lot of code that you tend to write, both at a function level when you are making calls to other areas and then across an entire package. So you have this, what do you know in your main world? You know your interface definitions and your type definitions. That's the thing that you control. You've decided what are the skills my characters have and what are the skills my other characters have. Then you move forward into actually doing the work. And at this point you're going to try. You're going to see what happens. You're saying, "Here's the problem. I'm going to take action in this way and see if it works." The like crux of the hero's journey, which this picture calls the abyss, death, and rebirth. I think that's a little extreme, but it's just the picture I found. The crux of it would be when you finish your calls out, when you finish your business logic, did it do the job that I wanted it to do? And did I check that it did the job I wanted it to? I think that's a point where a lot of times when you're programming, you might forget to do it or might not do a great job with it. But if you get it correct, you kind of wrap up your hero's journey. You get to check the performance, check that the value is returned, and hopefully successfully move forward with your little journey there. So I wanted to share that part because I thought it was kind of fun. And hopefully this can all help you think about how to write your code, especially when you're feeling blocked. Think about alternative ways to design your packages, both for yourself and with your teammates. And I just want to thank you all for being here.